Welcome to part two. In part one of the series, we talked a little bit more about what AI is and why now. In part two, we'll talk a little bit more about where AI is today and get into machine learning, which is the core technology that's at the heart of AI today. So, in the last video, we discussed how people equate AI to narratives popularized by Hollywood. But to really understand where AI is today, we have to understand the differences and similarities between Netflix's movie recommendations and the movie iRobot. So when you turn on Netflix and movies are recommended to you, what's really happening there is an algorithm that processes various characteristics of all the movies that's out there in content, looks at your viewing patterns, compares you with other people who are similar to you, and comes up with a very, surprisingly accurate recommendations of what you should watch next. And most of us are really happy with taking that recommendation. That is an actual classic problem that is solved by AI today. It's an example of an AI in action. It's very prevalent. It's not just in the Netflix movie recommendation engine, but when you go through Amazon and you select something and you're going and checking out in the cart, you might also want to consider some other options and things like that. All the different recommender systems are all classic examples of machine learning or AI in action today. But in the movie iRobot, where robots with high human level or higher than human level intelligence existed, what started as a simple movie plot turned out to be a real doomsday scenario where the machines take over and enslave humanity and just completely turns humanity into cattle, right? A fully automated machine in that movie exists among humans, demonstrates superhuman capabilities, the ability to think, act, perceive, do it faster, better, and more efficiently than human beings. It also had the intelligence to organize among itself, to stage a coup, and you got to love Hollywood for that. You see, the Netflix example is something that we see everywhere, and that is very, very prevalent form of AI today. But the iRobot example, you don't really see that. You don't have these smart robots walking around and staging coups against humanity every other day. Well, the reality is AI is actually two separate ideas. The Netflix example is an example of an idea that is artificial narrow intelligence. It's an idea that you take a narrow task and you train a machine learning algorithm or a machine to do that as good or even better than human beings by providing a lot of data, a lot of annotation, a lot of help, and you develop competency in a narrow task. Even playing games, all those examples are examples of artificial narrow intelligence. The second idea is the artificial general intelligence or AGI. And when you take an example like iRobot, that's an example of AGI. It's like human beings. We understand algebra, but we also speak a couple of languages. We can do things with our left and right hands. We can walk, we can run. There is so many different domains of knowledge and intelligence that we have to garner to be able to perform as a human being. And an AGI is an aspirational vision to get there, to really build all that human capabilities and even superhuman capabilities as we go forward. The idea of AGI is a great idea. It's the moonshot of AI among researchers. But it's not prevalent today. AI, the artificial narrow intelligence, is now and is today, and that's the most prevalent form of AI, most effective form of AI that we see today. AGI is pipe dream. It's probably centuries or even thousands of years away before it becomes reality. Okay, with that out of the way, let's talk about machine learning. Machine learning is a common form of AI where you write a software program that is then trained with data, usually historic data sets, to perform a task with or without human supervision. Now, if this training or teaching the algorithm to do something without explicitly telling it what to do is done with human supervision, you call it supervised machine learning. And if you do it without supervision, it's called unsupervised machine learning. Human supervision in this regard comes from taking the data that you're training the algorithm with and labeling it to say, for these inputs, these are some outputs historically. And that gives the machine enough fodder for it to learn from those correlations or connections within the data to say, the next time you give me an input, I'm going to give you an output. That is a classic example of supervised machine learning. The process of labeling that data set is called data labeling, and the end result is a labeled data sets. The process of training that machine learning model with the data is training, ML training. Okay, let's look at a few examples here. If you want to predict whether houses in a certain neighborhood is going to sell within 7 days of listing, and you will look at all the historic data of all the houses in that neighborhood or other neighborhoods, and how different characteristics about the house and the seasonality, the number of bathrooms and bedrooms, and pool versus not, and all those different characteristics. When you take all of that and you train a machine learning model to look at all that data, understand the connections within the data by helping them see those connections by labeling that data, that's an example of supervised machine learning in action. It's usually used for problems where you're trying to get a yes/no answer, whether you're trying to predict something, whether an event will happen versus not, and so forth. Although it sounds very simple, it can get really, really, really complicated. And I must say, this is probably one of the most powerful and prevalent forms of AI. And the advantage being you get a high degree of accuracy when you predict using supervised machine learning models. But the flip side of that is you have to spend a lot of energy, time, and resources labeling that data, collecting the data. There's a lot of pre-machine learning work that you have to do for supervised machine learning to be successful. Then came the other form of machine learning called unsupervised machine learning. And like the name goes, it's unsupervised, so no supervision by a human being. So usually these are algorithms that discover really hidden patterns within data. Usually they look at data groupings and how certain parts of the data behave when things happen. It's very exploratory in nature. And the ability to uncover these similarities and differences in information makes them really ideal for data exploration, for customer segmentation, understanding different segments, what we call clustering in the technical parlance, pattern recognition, and so forth. So some examples of unsupervised machine learning are using past purchase of data and customer characteristics to predict what to upsell and cross-sell is an example of an unsupervised machine learning. Another example is anomaly detection, where you can use these models to comb through really large and disparate data sets to look for anomalies in behavior. Computer vision or perception tasks, you're trying to identify objects within a picture or a video, are all classic examples of unsupervised machine learning. So unsupervised machine learning and supervised machine learning, two common methods of it. The advantage with supervised machine learning is its higher degree of accuracy, but the flip side is you spend a lot of time trying to label, collect data. Data collection, data preparation takes too long. On the unsupervised machine learning, you are, much lower degree of accuracy, but it's a lot more efficient way to do predictions. Now, both have challenges. So then came the new member of the brethren called semi-supervised learning, which is semi-supervised learning offers a happy medium where you take a small amount of data sets and you annotate that data sets, train the model with it. So the algorithms have to be written slightly differently. And then you actually use that to go discover from a larger data sets. And that way you're getting the best of both worlds, lesser effort, higher degree of accuracy without going through all the effort that you would do in a completely supervised machine learning process. So that's a lot of learning. I hope you enjoyed this. In the next video, we'll talk a little bit more about deep learning, which is another subset of machine learning that is, really, breakthroughs happened over the last decade, and it's the most fascinating part of artificial intelligence. Stay tuned.